So let's start things off with the first question as well. So since dCS is a pillar in digital audios, the first one would probably be the DAC and ADC design, the 900 and 950 still used today in studio, and nowadays dCS is known as like a statement, a leader in high-end digital audio as well. So I was wondering if with like 40 years of experience with DAC design philosophy, DCS audios, and a lot of customers are very interested in DCS thought about the DAC itself because there are a lot of factor in DAC design, isn't it? Like the analog design, we have the IV conversion, there's low pass filter. On the DAC itself, there is R2R, there's Ring DAC, and Delta Sigma. A lot of it. So I have sent you the question, and you see there's 1 to 6. So there's dark software, their power, their clock, and also everything else like the network, digital input, everything like that. So with this said, what do you think is the most important factor in the following order, and also which contribute to the higher sound quality that this is well known for?
This is a really interesting question. So a lot of, well, really all of the elements that you've mentioned there, they have a lot of interplay. They interact with each other in a lot of very complex ways. So on the one hand, it's quite tricky to separate them out. For example, whatever your DAC architecture is, whether it's the Ring DAC, whether it's an R2R DAC, whether it's a Delta Sigma DAC, it needs a very good clock signal fed to the DAC so that it can perform those conversions at the right time. If the power supply that you then feed to that clock circuitry is in any way compromised, you get compromised clock signal, which means your DAC architecture is then compromised. So everything has to be working together at a very, very high level, and there can't be any weak links in the chain for really high performance out of a product. But if I was to select what, in my opinion, would be the most important factors, I would say the DAC architecture and the DAC software working together. Those are the two most important factors. So as you're probably aware, with something like the Ring DAC, the DAC stage itself is operated by FPGAs, which contain the mapper software, a lot of the filtering software. So the hardware and the software really work together in that sense. So I would put those as the most important. In terms of the second most, then I would probably put the analog stage, the power supply, and the clock together, because they form all of the fundamental supporting hardware that allows the DAC to operate correctly. And then below there, I would say all the other elements you've listed, things like the USB receiver and the network. So yeah, top DAC architecture and DAC software. Second would be analog stage, power supply, and clock, and then followed by all of the other elements.
Yeah, thank you so much because that cleared out a lot of question in the audiophile and also in headphile community as well because like most people divide DAC into two camps. Once is Delta Sigma or R2R ladder to that, and people oftentimes they don't really know what exactly is DCS Ring DAC is. Although it has been with DCS about like 40 years, nearly 40 years now, and so a very interesting question about DCS Ring DAC is like so with all the previous iteration of Ring DAC itself, it's nearly 40 years old. But nowadays, like in last year, you introduced the dCS Ring DAC Apex coming to the Battalk, the Vivaldi, and Rossini as well. So what is the difference what is the breakthrough that you changed entirely the name of the Ring DAC itself? Like add surface into that.
So we have quite a long history of Ring DAC hardware advances as technology has advanced over the years. So to give an example of that, when we moved from our previous generation of products, which would have been the Scarlatti, the Paganini, the Puccini, the Debussy, when we moved from there to our current third generation of products, the Ring DAC circuit itself went through a major rework at that stage. So, for example, on the previous generation Ring DAC, we had 4 current sources within the DAC. The latches for those current sources existed on a single IC, a single integrated circuit. When we moved to the current generation Ring DAC, those were split out into individual latch ICs. This was something that was enabled by increases in technology since we'd made the second generation, and it led to, for example, better crosstalk between the current sources on the Ring DAC. So we are continually pushing the hardware that we're using within the Ring DAC over time, but crucially, the fundamental design concept of the Ring DAC is a very, very solid concept to use. So it's something that has existed for this long, while maintaining its sort of place at the top of the industry. Apex is quite an interesting one. So with Apex, this is very much the next stage in the hardware design of the Ring DAC. So there are three main areas that I would talk about where we've improved the hardware design with Apex. So the first of which is an improved power supply. So the Ring DAC is what we could call a multiplying DAC. We take a reference voltage, a reference power supply that we're feeding into the DAC, and we multiply this by however many current sources are turned on within the DAC to generate the right voltage at the output. Now, if we have anything not quite right about the power supply that we're feeding to the DAC, any sort of ripples on the power supply, these get multiplied up when we then activate several current sources. So this problem becomes quite pronounced on the output stage. So what we've done with Apex is we have lowered the impedance of the signal path that feeds this reference voltage to the Ring DAC. So what it means is, as those current sources are switching on and off, as they're creating the voltage that we need on the output, they have much less impact on the power supply feeding into the latches themselves. That power supply signal path is much more resilient to the sort of impedance changes we get as we're turning these current sources on and off. So we get a much more consistent performance from the DAC. The second place, which is quite similar, is with the clocking. So we need to feed the clock signal generated by the clock circuitry into the Ring DAC, and it needs to reach all of the current sources at exactly the same time. So it's quite a crucial thing to get right here. And again, what we have done is we've reduced the impedance of the signal path that feeds this clocking signal into the Ring DAC. So again, we've made the DAC more resilient to intrinsic jitter. You're going to get better jitter performance out of the product. And then the last place would be, we've reworked the analog circuitry which exists on the output stage of the product. So this was enabled by the increases in the sound quality of the product that we've done in software. So with something like the Bartok, when we released the Bartok 2.0 update last year, the increase in performance in the product meant that we were then able to really delve into exactly what was happening in the analog output stage, really with a finer level of detail. So we started looking at interactions between components in the analog output stage and how they interacted with, let's say, more esoteric cable designs and amplifiers that the unit is connected to. So ultimately, this rework in the analog output circuitry means that the Ring DAC is significantly more linear. So we have a much, much lower level of harmonic distortion that the product creates. So really the crucial harmonic here is the third harmonic. This is very, very noticeable to the human ear and the human brain. And we are about 12 dB lower on the third harmonic with Apex than we were prior to Apex. And I should note that even with the pre-Apex version, we had really world-leading performance in harmonic distortion. So Apex is a significant step forwards. And then combine that with, we have a lower noise floor with Apex, and there's a lot of other improvements as well. But the big key one for me with this reworked analog output stage is that lower third harmonic distortion.
I think so, yeah, because especially for even experience throughout the line with Vivaldi Apex or Rossini Apex and the Bartok Apex I have reviewed, I think the sound is much more warmer, more musical. I think that contribute a lot due to the third harmonic distortion. It's much lower compared to the older generation as well, I think so. And also with the power supply to the Ring DAC itself and the clock circuitry, with the lower resistance, I think it also requires a hardware change that needs to be done with the Ring DAC Apex board itself. And it's very interesting design that I was asking Mr. Wright before that why does the Ring DAC itself between the Ring DAC Apex board itself, between the Vivaldi, Rossini, and the Bartok is essentially the same, isn't it?
Yes, that's correct. We're using exactly the same circuitry between all three of them. So a customer with a Bartok who upgrades to Apex has exactly the same Ring DAC Apex circuitry as a Vivaldi Apex DAC customer. But this is quite a core aspect of dCS circuitry, is that the hardware is very, very similar between all of our products. So we're not compromising on hardware as you move down the range. The Lena DAC, for example, uses exactly the same clock crystals as the Vivaldi DAC, as the Vivaldi clock. We're using the same grade resistors inside of the Ring DAC circuit. So the core hardware of our products is always full fat dCS, as you could say. So it's, we're not making any compromises in terms of hardware anywhere. And Apex is a really good example of that.
So the difference itself is based on the supporting platform on the Ring DAC between the model as well. So for example, for the Bartok, you have only one transformer, I would say, and then going up to the Rossini, then there's two transformer, and also going up to the Vivaldi, there's more complex transformer. Also the DSP, the digital signal processing, also more complex compared to the lower tier like Rossini and Bartok, isn't it?
That's exactly right. Yes, and I think dCS is quite unique because we're in a position where we can engineer our products top down. So the Vivaldi was the first product that we created in our current lineup, and this was back in 2012. And what that enabled us to do was to take everything that worked really well about the Vivaldi system and refine it down into, first of all, a lower number of units, a smaller number of boxes, and to bring it down to a more accessible price point as well. So that was an exercise in how do we take everything that's great about the Vivaldi and refine it down. And that's what led to something like the Rossini DAC or the Rossini player, which are all-in-one systems. You only need the one box, connect that up to amplifiers or even straight to a pair of active speakers, and you have a whole music system with one box. And then moving down to the Bartok again, how do we take everything that makes the Rossini so special and refine that down and make it again more accessible? So as you mentioned, we have a simplified power supply within the Bartok, but the core circuitry is all identical. The same Ring DAC, the same analog circuitry. The chassis is a little bit more simple, as you will see on the Bartok as well. Yeah. So the Rossini, obviously it has that gorgeous sculpted fascia, but it also has some special sub-chassis within the product to mechanically isolate important parts of the circuitry from any sort of vibrations that might impact them. But they're very specific places where we simplify the products moving down the range, as opposed to, for example, we're not simply just choosing cheaper componentry to use inside. The core of the dCS DAC is the same, irrespective of which model you choose.
Thank you so much. And of course, this one question would be kind of like tricky and tough itself, because some critics say that since the dCS Ring DAC has been stable between dCS DAC throughout the year, that it's not improved enough between the model each year, between its iteration. So what is your response to that criticism? Because that they will always say, okay, so it's dCS, so it will sound, they have a house sound, they sound similar, so you don't need to upgrade into this model, that kind of stuff. You know what I mean, right?
Yeah, and that's a really good point to raise. So what I think is interesting here, I would consider that a bit of a compliment, actually. So there's two areas that I'd think about this with. So first of all, we've retained the same design philosophy of our products really for as long as we've been making digital audio products, and that's both for the Ring DAC itself and for all the supporting hardware and software. So the company tagline for dCS is only the music. So this means that the DAC needs to be completely transparent, and it's not imparting anything onto music. It's not adding in distortion or noise. It's not adding jitter. It is staying out of the way and being a piece of glass that you, the listener, are using to get inside of the music with. And it needs to do this irrespective of what source material you're playing, what cables you're using, what the amplifiers or speakers or headphones are that are connected. So that's quite an engineering task, to have a product that can maintain transparency through any conditions that you throw at it. And to maintain that sonic signature over such a long history of making digital products is, I think, it's quite a feat. And it's something that we're very, very proud of. We very much have stayed away from engaging in a specifications arms race. So, you know, chasing numbers-based specifications like higher and higher sample rates. And instead, what we've done is we've focused our engineering resources on providing improvements to our customers that don't require very niche audio formats or anything specific. The benefits of something like Apex, for example, they bring as much benefit to a user who is playing MP3 files as they do to a customer who's listening to high-rate DSD files. So we've very much focused on providing value to every customer, as opposed to the small subset of customers who might want to be engaging in very, very high sample rates. They still receive the benefits of Apex, but we're doing it for all customers. So yeah, to come back to the original point then, I think we also very much want to provide a long-term investment in a dCS product. So the fact that one can listen to, for example, a Scarlatti system and still be absolutely blown away by the sound quality of it is a real testament to how well dCS systems perform over time. And there's a lot of elements, Scarlatti DAC that you purchased back in 2009 still performs just as well as it did when it left the factory in 2023. So it's very much not the case that we would say, right, you know, the Vivaldi range has come out, your Scarlatti system is now obsolete, and, you know, it's still a fantastic performing product. We released software updates for the Scarlatti system after we had ceased production and begun production on the Vivaldi, because we wanted to honor the investment that those customers had made. So while some may see it as a criticism that I think the house sound of dCS has remained the same, and that it's just been improved upon over time, I see that as a real positive.
Thank you so much for answering that question. And also, since you have said that, okay, so once you buy a dCS product, it's a sound investment throughout the year. I want to ask you a little bit, since like I see that dCS is moving into a new direction with modular design, because like customer that buy dCS Bartok 1.0 or Vivaldi 1.0, the original one, they now can upgrade to the Ring DAC Apex module board, the Ring DAC Apex board, with an additional price that just they can keep like their original unit, but upgraded to a Ring DAC Apex that sound and performance like exactly the same with the new Apex that brand new. So I was wondering, is it the modular design approach would be like a new direction, a moving direction for dCS in the future as well?
So dCS have actually had several hardware upgrades which have been made to some of our products over the years. So the most recent before Apex would have been with the Vivaldi upsampler in 2016 with the Vivaldi 2.0 update. So prior to that, we had updates to some of our master clocks that had been used previously in the second generation of products. So where necessary, we are always willing to provide upgrades to the hardware of our products. With Apex, what's interesting there is, personally, I think a lot of companies would have opted to release Apex variants as entirely new products, and required customers to get rid of their existing DAC and then repurchase a whole new unit to go with it. You know, for us, the performance jump was substantial enough that I think we could see a lot of companies going that way. The hardware flexibility of our platform, though, so the modularity, as you've said, of the Bartok and the Rossini and the Vivaldi products, combined with our desire to provide value to our customers and honor their investments over time, is what enabled us to offer this as an upgrade to existing customers. And as you alluded to, if a Bartok customer upgrades their Bartok to Apex, it is exactly the same as a Bartok Apex that we would produce in the factory brand new today. So the hardware is identical between the two. There will be absolutely no discernible differences between those two units. So the customer that has already invested in the Bartok and then chooses to further that investment with an Apex upgrade is right at the forefront of what we're offering. With dCS, we're always performance and engineering led. So when something like Apex comes about, when there is an advancement that is made, we always consider what the best way is to deliver that to our customers. So where it's possible, we offer these improvements as software updates. But what you come to is a point where the software capabilities of the product outstretch the hardware performance. And what that allows you to do, like what happened with Apex, is to further improve the hardware design to then match that. So as I mentioned earlier, the 2.0 updates on the Bartok, the Rossini, and the Vivaldi are part of what enabled us to then further the hardware performance of the product. So the two sort of go in lockstep, if you will. Yeah.
Yeah, thank you so much. And especially since you mentioned that the 2.0 firmware update, I want to ask you a little bit about this dCS Lina 2.0 update as well. Because essentially, with the new firmware update, it basically they transform Lina DAC into basically a new DAC with a new performance level as well. There's new function, preamplifier, mapper, also the filter, all kind of that stuff. But so is the software upgrade will providing a long time like value to existing products, and it will how can a simple firmware update that basically transform the DAC unit into basically sound so much better? I was just wondering why.
Of course. So software updates have been part of the DNA of dCS really almost as long as we've been making products. So there are only one or two products, I think, that we have made in our entire history that weren't run by FPGAs. And these are the very, very early. So, for example, the dCS 900, which was the first analog to digital converter we made, didn't use an FPGA, but we very, very quickly started implementing them to run really all functions of the product. So FPGAs are, very difficult to work with. They require a lot of expertise to utilize correctly. But when you do, it gives you a level of control over the entire product, which you can't get otherwise. And being field programmable, as the name would suggest, you can change how they operate over time. So, of course, dCS isn't the only company that is manufacturing digital audio products with FPGAs, but I think we utilize them the best in the industry. We ship our products with a huge amount of headroom within the FPGA to allow for future updates to be provided. So DAC, for example, has a huge FPGA inside of it with lots of free space available for us to implement new features over time. So the capability for the product to be improved over time is built in right at the conceptual stage. Now, with Lina, we've already seen a number of updates. So I believe it was back in March this year, so 2023, that we released the preamplifier functionality with the Lina DAC. So we started to see the DAC used much more in two-channel loudspeaker listening systems. And as a reaction to that, we spent some time redesigning the user interface of the DAC to allow it to be used for digital volume control and making sure that it could be paired up with really anything you wanted to plug it into, any kind of amplifiers and cables, and really testing it in two-channel systems and making sure that it hit that performance level that it needed to. The 2.0 update has brought some further features as well. So obviously, as you mentioned, the mappers, the filters, the parts of the product that really increase the sound quality, those all live within the FPGA of the product. So it's what enables us with a 10-15 minute internet-based firmware update to completely change the sound of the product and raise it to a new level. Now, yeah, this is something that dCS have been doing really for as long as we've been making products, and we are absolutely not finished. So this is part of what allows our products to be so long-standing, to have such a long life. The Vivaldi was originally launched in 2012, and today it still sits at the forefront of digital audio systems. So I would wager that there aren't many products released in 2012 which are capable of streaming, for example, Tidal, Qobuz, Spotify, Deezer, Roon, let alone doing it with audio quality like the Vivaldi has with the Apex upgrade and all of the performance enhancements that brings. So in terms of upgradability, that's absolutely something that we're committed to. And yeah, we have plenty still to come with our current products.
Yeah, so it's very interesting that you bring up the FPGA design, because I think is it the improvements in the FPGA capability that bring out the more faster mapping design as well, because like I see when 5-bit modulation in the FPGA in the dCS design, right? Now basically run at double speed, like 5.6 megahertz is double speed, and we were taxing a lot on the FPGA itself. So is it true that the FPGA improvement over the year that bring out in more details compared to the previous generation, the older one like Scarlatti and something like Rossini Perso as well?
So yeah, having the additional headroom in the FPGA definitely is part of what enables us to do that. On top of that, what's quite unique with dCS is that obviously we have quite a specific product range. So really, we've been improving on that same software for 35, 40 years. But yeah, the hardware improvements that the market has seen in terms of FPGA capabilities is definitely something that's enabled that. And there are other elements to that as well. So when we look at, for example, the Bartok, we have 3 main FPGAs inside of the product. We have an FPGA which sits on the control board that looks after a lot of the DSP functionality, so the upsampling, the filtering. We have an FPGA for each channel as well that exists on the Ring DAC circuit board that looks after the mapper functionality. Now, with something like Lena, where we needed to take all of the circuitry from within something like the original Bartok and justify it down into a chassis which is under half the size, one of the areas that we needed to do that with was to unify those 3 FPGAs onto one single very powerful unit. So not only has the improvement in things like FPGA technology allowed us to provide sound quality increases to our customers, it's also allowed us to bring that technology to a much more compact form factor and a much smaller chassis size while retaining all of the key features of a full dCS DAC.
And thank you so much, especially after experiencing dCS Lena 2.0 today. And I can say that it's a very terrific product itself. Like I would say it's not entry level. I think it's a state-of-the-art DAC with a bargain price in dCS lineup. Very sweet spot. And I would say thank you so much for doing the interview today, because like I have so many questions more itself, because due to like mapping, modulation, multi-bit DSD, and all kind of stuff. For today, thank you so much for introducing us to dCS philosophy and DAC design. Thank you.
Yeah, thank you so much for talking to us, and yeah, hopefully we can chat about those things in the future. I look forward to it.
Thank you so much.